This is chapter number 5, Arithmetic Progression, class 10, page number 93 NCERT book. 5.1 Introduction. You must have observed that in nature many things follow a certain pattern, such as the petals of a sunflower, the holes of a honeycomb, the grains of a maize cob, the spirals on a pineapple and on a pine cone, etc. Now we look for some patterns which occurs in our day-to-day life. Some such examples are: first, Reena applied for a job and got selected. She has been offered a job with a starting monthly salary of rupees 8,000 with an annual increment of rupees 500 in her salary. Her salary in rupees for first, second, third, and many years will be referred respectively 8,000, 8,500, 9,000, and so on. Second, the length of the rungs. The length of the rungs of a ladder decrease uniformly by 2 cm from bottom to top. See the figure 5.1. The bottom rung is 45 cm in length. The length in centimeter of the first, second, third, eighth rung from the bottom to top are respectively 45, 43, 41, 39, 37, 35, 33, 31. Number 3. In a saving scheme, the amount becomes 5 by 4 times of itself after every 3 years. The maturity amounts in rupees of an investment of rupees 8,000 after 3, 6, 9, 12 years will be respectively 10,000, 12,500, 15,625, 19,525.25. Number 4. The number of unit squares in squares with the sides 1, 2, 3 units. See the figure 5.2. Number 5 are respectively 1 square, 2 square, 3 square, etc. Number 5. Shakila put rupees 100 into her daughter's money box when she was 1 year old and increased the amount by rupees 50 every year. The amount of money in rupees the box on the first, second, third, fourth birthday, 100, 150, 200, 250 respectively. 6. A pair of rabbits are too young to produce in their first month, in the second, and every subsequent month they produce a new pair. Each new pair of rabbits produced a new pair in their second month and in every subsequent month. See the figure 5.3. Consuming no rabbits dies. The number of pairs of rabbits at this start of the first, second, third, and so on after the second and sixth month respectively are. In the examples above, we observed some patterns. In some, we find that the succeeding terms are obtained by adding a fixed number in other y, in other by multiplying with a fixed number in another. We find that they are squares of consecutive numbers and so on. In this chapter, we shall discuss one of these patterns in which succeeding terms are obtained by adding a fixed number to the preceding terms. We shall also see how to find their nth term and the sum of n consecutive terms, and use this knowledge in solving some daily-like problems. 5.2 Arithmetic Progressions. Consider the following list of numbers: 1, 2, 3, 4, second, 100, 70, 40, 10. Number 3, minus 3, minus 2, minus 1, 0, dot, dot, 4, 3, 3, 3, 3, dot, dot, dot. Fifth, minus 1.5, minus 1.5, minus 1.0, minus 1.5, minus 2.0, minus 2.5, dot, dot, dot. Each of the numbers in this is called a term. In a term, can you write the next term in which the list above? If so, how will you write it? Perhaps by following a pattern or rule. Let us observe and write the rule number in each terms one more than the term preceding it. Number one, two, three, four, dot, dot. Here, any term is added one to the preceding term. Number two, 100, then 70, then 40, then 10, then minus 20, and dot, dot, dot. Here you can see if the term is subtracted 30 to the preceding term. Number 3, minus 3, minus 2, minus 1. Term is added 1 to the preceding term. Number 4, 3, 3, 3, 3, 3, 3, 3. Term is added 0 to the preceding term. Number 5, minus 1.0. Term is subtracted 0.5 to the preceding term. Each of the numbers in this list is called a term. Given a term, can you write the next term in each of the list above? If so, how will you write it? Perhaps by following the pattern or rule. Let us observe and write the rule. In one, each term is one more than the term preceding it. Second, each term is 30 less than the term preceding it. In 3, each term is obtained by adding 1 to the term preceding it. In number 4, all the terms of list 3, that is, the terms is obtained by adding or subtracting 0 to the term preceding it. In 5, each term is obtained by adding 0.5, that is, subtracting 0. From the term of preceding. In all the list above, we see that the successive terms are obtained by adding a fixed number to the preceding term. Such list of numbers is said to form an arithmetic progression. AP. So an arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term, except the first term. The fixed number is called the common difference of AP. Remember that it can be positive, negative, or 0.